Good afternoon, everybody. My name's Oliver. I'm from Widex in Copenhagen, and here are some of my Danish colleagues on the screen who helped realize a piece of machine learning technology and also produce some of the data that you're about to see. As Widex has been exploring new technologies, we've looked at various models, and I've seen a lot of advances towards the ideas that we can put things in the end user's hands that can help them evaluate where they are, share information with their audiologists, and also make more and more complex controls. And this is really about addressing that the hearing is happening in real life, in the moment, and that's where we want to be with our users. And the machines are coming, so surely they can help us, and when they're here, I really do worship you. But they're tools for us to do better things for our clients. And they're not here to replace us. They're here to help us produce better outcomes, provide better services overall. Of course, I don't need to tell you that modern hearing aids today are becoming increasingly complex. But as a profession, we are very good at fitting these products in the clinic and sending people out into the real world so they can go and use and enjoy them and get increasing benefits from them. Just a couple of quick definitions that artificial intelligence as a whole is a huge, broad subject area, and machine learning is just one part of artificial intelligence. Machine learning is very good at looking at data, analyzing it, and predicting outcomes and telling us where that data could or couldn't go in the future. And one thing it's good at doing is learning to play games, for example. Here we see a very famous machine learning computer, Google's DeepMind, which was actually able to defeat a world champion at the strategy game Go. And it learned to do this all by itself. What we are hoping to do at all times with our hearing aid design is, of course, make the most automatic system possible. If something is truly automatic, someone can get on and use it, and this will reduce cognitive load. They can get on with the task that they've come to seek help for, which is listening. But automation has built-in assumptions about what the user wants to hear. So what happens when an automatic system doesn't quite meet their assumptions? Well, they pick up an old-fashioned phone and call you, or they'll reach for some controls in the hearing aids, which are becoming increasingly more complex, or they'll just put up with the problem and put the hearing aids in the drawer. But what if there was some way that we could reach the listening intent of the user and find a system that could somehow create or offer us suggestions for those matching hearing aid parameters to meet the listening intent? And we believe that machine learning should allow us to do this. The advantages of machine learning over previous explorations of systematic adjustments of parameters is its speed and power and not increasing its terms of questions it has to ask. So I think the logo is wrong there, actually. So anyway, and the fonts have gone a bit wacky. So I can remember the maths in my head. If we're going to do a paired comparison between some hearing aid parameters, so if we've got 3 parameters with 10, that means there are 1,000 combinations. And if we're to produce a system that compares every single comparison against each other, we have to do 500,000. So the machine learning algorithm can do this in just 20. Now, I'm talking about something that we're putting in the real world, but we actually had to do a lab trial, which seems a bit ironic, to produce some empirical data to talk to you about. And I'm going to run out of time on that one. So the machine learning algorithm sits behind a very simple interface. Behind an A and B comparison are a set of hearing aid parameters, and all the user had to do was rate, using the slider, which set of parameters they preferred. They literally pointed to which set of parameters sounded better. They would then listen to these sound scenarios, create their own programs to provide a solution for that sound scenario, whether this was we were looking for increasing sound quality or increasing comfort. They went away, and then when they came back, we asked them to rate the program that they had created against a program with no automation, a program with the full hearing aid automation, and then their own program. And we can see that we had subjective improvements in both sound quality and comfort from no automation, and the machine learning created program. And these results were consistent across all of the samples that we used. Here we can see increases in subjective ratings for comfort across a canteen, dinner, and road noise scenario. And we also saw increasing subjective ratings for sound quality when we looked at the music samples as well. We had 2 contemporary music samples and a classical music sample. But what was really interesting was that the program that they had created themselves was incredibly personal to them. It was their creation versus what had been assumed by us, the manufacturer, and the hearing aid automation. Head to head, we saw consistently that the machine learning created algorithm was outperforming the unautomated and automated program. But where the automated program reached the intent of the user, there would actually be no need for them to have created the program in the first place. So they didn't lose anything in doing so. But when we looked at the mapping of the spread of the different parameters in the individualized programs, we saw they were just that, quite individual to the end users. So they were achieving an improvement with something that they had created themselves very simply through a very simple interface, but with the power of machine learning behind it. So we can account for, with the backing of the machine and the help, for auditory intention in a given scenario, in a real-world moment, when someone's having a program, they can reach out and help themselves straight away. I think I may have said that a little bit fast, but there you go. Thank you for your time.